Okay, in this video we're going to look at compounding interest. So let's take a look at example number 1 from your notes. If $400 is invested at 5% per year, compounded annually, what's the total amount after 6 years? Okay, so we recognize this as an exponential growth type problem, which means we're going to be using y equals a times b to the power of t, our standard form of our exponential function. And we just need to know what are going to be our values of a and b. A is our initial value, b is going to be our growth factor. And once we have those two values, well, we can just plug in t equals 6 here, and we can calculate the amount of money we're going to have in our account after 6 years. Okay, so let's do that. So a, and remember a, that's my initial value. So a is just given to me in the problem, that's $400. Okay, my initial value is a. Now b, in order to calculate b, that's my growth factor. And I remember in order to calculate my growth factor, I need to know my growth rate. So r, that's my growth rate. And r is also given to me in the problem, it's 5%. Although, I remember I have to express that percentage as a decimal. So, 0.05. Okay, now I've got r, my growth rate. And now I'm ready to calculate b, which is my growth factor. And my growth factor, I can calculate using this little equation here, 1 plus my growth rate. Well, I already know my growth rate, it's 0.05. So 1 plus 0.05. And now I have b, my growth factor. So now I have everything I need. I just plug in a and b here into my function. A is 400. B is 1.05, like this. 1.05 to the power of t. Now, if I want to know the total amount that's going to be in the total amount of my investment after 6 years, well, I'm just going to calculate the value of y after 6 years, 1.05 to the power of 6. And if I punch that into my calculator, I get $536.04. All right. Okay, so far so good. Now the next example, we're going to look at what would be the amount in our bank account if we didn't calculate our interest once a year, but if we calculated it more often than once a year, and that's called compounding interest. So let's take a look at that example. So example number 2, the same $400 is invested at 5% per year. Again, that's the same interest rate that we had before, except this time it's going to be compounded semi-annually. In other words, instead of calculating interest and then adding that to the account once a year, we're going to be doing it twice a year. All right, so once in the middle of the year, once at the end of the year. So now, again, we want to know the total amount after 6 years. Okay, well, again, I recognize this is going to be an exponential growth problem, which means I'm going to be using my exponential, the standard form of an exponential function. This time, however, I'm going to write it like this. Instead of writing it a times b to the power of t, I'm going to write it as a times b to the power of x. And you're going to see why in just a minute. Okay, so now, once again, I need to figure out my values of a and b, my initial value and my growth factor. All right, well, my initial value, a. Again, that's the same thing it was before, $400. All right. To calculate my growth factor, again, I have to have my growth rate. And now here's where it starts to get a little different from the example that we had before. The growth rate is given to me in the problem, but notice my growth rate is given to me as a yearly rate, an annual rate. 5% growth per year. And yet I want to compound my interest, that is, I want to calculate my interest payments every half year. All right, so I don't want to use an annual interest rate if I'm compounding semi-annually. I need a semi-annual interest rate. Well, the way I do that is, instead of getting 5% per year, since I'm going to be calculating interest every half year, well then I just take my yearly interest rate and I divide it by 2. So my growth rate is going to be 5% divided by 2. That is my annual growth rate divided by 2, which gives me 2.5%, or, remember I have to write that as a decimal, 0.025. All right. Now again, remember this value right here, this is my growth rate, but more specifically, this is my semi-annual growth rate. All right. My annual growth rate was 0.05. My semi-annual growth rate is 0.025, half of my annual growth rate. Okay, so now I got R, my growth rate. Again, I want to calculate my growth factor, and my growth factor is 1 plus my growth rate. I have my growth rate here expressed as a decimal, 1 plus 0.025, which is 1.025. Great. Now I've got A, I've got B, so let's go ahead and put those in. Y equals 400 times B is 1.025 to the power of X. Okay, now we need to talk about what is this value here going to be. So in the previous example, the value here was just 6 because we were talking about A times B to the power of T. And T, we've been talking about how, well, that's time, and we've leaving our money in our account for 6 years. So you would think, well, that's how long we are going to be leaving our money in here, so wouldn't that number be 6? Except that number here is really not, it's not time, it really is how many times are we going to be calculating interest on our money. And in our first example, we calculated interest on our money 6 times at the end of every year. Well, now we're not going to be calculating interest 6 times, we're actually going to be calculating it 12 times because we are compounding interest semi-annually. That means we are going to calculate interest in the middle of the year and at the end of the year. Well, since we're doing that for 6 years, that's twice a year for 6 years, the value here is 12, or 2 times 6. All right, so this number here, it kind of has gone from being a time value to being the number of compounding periods, or the number of times we're going to calculate interest. So this value now is 12. Now I'm ready to calculate my interest, 400 times 1.025 to the power of 12, and I punch this into my calculator, and I find that the total amount in my account after 6 years is going to be $537.96, or a little bit more than I would have gotten if I had used annual compounding.